It's your friendly math tutor, Miss C here, and today we are talking arithmetic series. Series is another word for sum in math. So we are finding the sum of a specific number of terms in a series or in a sequence. That is arithmetic. So that means we take every term and add them together and we get a single number. That's what we're doing. And we're doing that specifically for arithmetic sequences. That is sequences that increase or decrease by addition or subtraction. All right, so let's get to it. So there are a number of different formulas that we use for this. This is my favorite formula. So you can, of course, use any that you like. But for today, I'm going to show you this one because I like this one. And I think it's the easiest to use out of most. All right, so this says the S of n. So this is series of n terms is equal to n divided by 2 times this massive quantity. So let's just define our variable. So S means series. And as a reminder, series is another way in math of saying sum. So we're finding the sum of n, which is some number of terms. Okay. And to do that, we have a letter A in here. This is our first term, or our starting term. Sometimes this might be U sub 1 if you're pulling from recursive formula. Again, variables are just holding the place, so as long as you know it's the first term, that's fine. And then D is consistent with our recursive formula, and this is the common difference. And that's essentially how much it's being added. Every term is added to or subtracted from. So you could think of it as like if it were a linear function like the slope. So I like to always start with n because that's usually given in the problem. And in this case, it's 50. A is 7 because it's our starting value, our first term. And D, so if we look at this, I'm increasing by 2 here. I'm increasing by 2 here. I'm increasing by 2 here. So we want to do 2 checks at this point. The first check is that, is it being added, a value being added or subtracted consistently? Yes, it is. So it's arithmetic. So we can use this formula. And we're checking to see what D is, which in this case is positive 2. So all we really do now is we substitute what we know into our series formula. So we say the series of 50 terms is equal to the number of terms, which is 50 divided by 2. So I went ahead and plugged in 50 for n. So you can see I'm going to plug 50 in where those are highlighted. And then I'm going to say times 2 times my starting value, which is 7. So if I grabbed a different color, you could see that I'm only plugging that in once where there is A. And then I'm adding the common difference of 2. So 2 is here, and that only gets substituted in once as well. Times, and these parentheses do matter, 50 minus 1. Okay, so the most correct way to do this would be to follow the order of operations and simplify what's in the parentheses first, and then work left to right with addition, subtraction. I'm going to or multiplication, division, and then addition, subtraction. I'm just going to work from left to right, following the rules that I know. So I'm going to go ahead and simplify this multiplication and division. I'm going to multiply here. What I'm not doing is adding things together until the multiplication is done. Okay, unless it's by itself in parentheses like the 50 minus 1 was. All right, so there we go. I'm going to simplify down just a little farther to put this into my calculator in a little bit of an easier way. And what I get is 2,800. So if I were to add all 50 of the terms up, starting with the first term, which is 7, and I added the first 50 terms up, I would get a sum or a series of 2,800. Okay, that's how you do that one. Let's look at how we would do one that is written in sigma notation. All right, sigma notation. If you've watched my videos, you know that I talk a lot about how math people don't like to write a ton. So enter a new notation, sigma notation. what this means, this big E is a Greek letter called sigma. And what it does is it tells us we are finding from term 1 to term 20 for this rule, 4n minus 6. So you could think of that as if you've learned explicit formulas with recursive functions or recursive formulas. This is what happens when you turn a recursive formula into an explicit formula. So, and look at all the words we saved by using a notation. So we use the same formula that we used on the last problem. I'm going to jot it down over here for us so that we have it. And you might want to consider jotting it down too, because the more times that you write it down, the easier it's going to be for you to remember it and have it in memory when you need it. Although you could derive it if you forget it on a test by just working through a couple of series. So options. So here we go. We know that the number of terms we're finding are from 1 to 20. So we're finding 20 terms, right? If I were to count on my fingers up to 20, I'd have 20 fingers up if I had 20 fingers. So there is that. And then I know that my first term I have to find. So let's go ahead and do that. I'm going to plug 1 in for n, and that's going to give me my first term because, if n equals 1, that's the first term. So when I do that, I get -2. So in this notation, it's not quite as easy. They're not giving you a sequence, so you have to find the first term. And then d is what's in front of the variable. So this would be like if you were writing an equation in slope-intercept form, it's the number in front of the x. You could just say the variable. So it's 4. So now we can just go ahead and plug things in to our equation. So remember, everywhere I see n, I'm plugging in 20. And everywhere I see a, I'm plugging in -2. Make sure not to drop that negative. And everywhere I see D, I'm plugging in 4. Okay, so let's do this. So I am finding the series of 20 terms. So 20 divided by 2. 2 times -2 plus D times 20 minus 1. And then I'm just going to simplify this so when I put it into my calculator, it's a little easier. You could put it into your calculator right here if you wanted to. But sometimes I just like doing math. So we're going to end up with 720 as the sum of 20 terms. Okay. So pretty much like the last one, you just have to know how to get the values out of this notation. Let's do one more that could potentially be a little trickier just based on the way it's written. All right, the way this problem is written, it says find the sum of the first 40 multiples of 8. So we really need to know something here, and that is what the word multiples means. So if you remember from elementary school, multiples is just another way of saying skip counting. So that means I'm looking for a sequence that grows by a multiple of 8. So starting with 8, 16, 24, 32, and so on. Okay, that would be the sequence. So just sometimes when you get these word problems, just make sure that you take a moment and dissect what they're actually asking for. So, and not too bad once we do that. So I'm going to go ahead and take the time. I'm rewriting this one more time. It's getting stickier in my brain every time I do that. So that's our formula. And now I'm just going to go ahead and write down everything that I know. So I know that I'm looking for the first 40 terms. Okay, so n is going to be equal to 40. I know that my a value is the first term or the first value of my multiple, which is 8, also my first term. And that if I'm looking for multiples, my common difference has to be 8, right? So 8 times 1, 8 times 2, 8 times 3, like that. All right, so let's go ahead and do the summation. So I'm looking for the series of 40 terms So I'm saying 40 divided by 2 times my first term plus my common difference times 40 minus 1. Now, if I were doing this on my own, I'm writing all of these things out because I'm doing a tutorial. I would go ahead and just say 39 instead of 40 minus 1. Of course, up to you how you choose to do this, but that might be a little bit of a time-saving endeavor. Since I don't know 8 times 39 off the top of my head, I'm just going to put this into my calculator straight away like this, and I'm going to get 6,560. That is the series of 40. What that means is when I add the first 40 multiples of 8 up, I get 6,560. And that is how you use arithmetic series or find arithmetic series. If you found this video helpful, please like it and subscribe so this video and many other math videos are available to others. Thanks for watching, and remember, you've got this.